Hi, everyone. Thanks for joining this new session of the webinar series dedicated to pSeven Enterprise. This is Laurent Chec speaking, General Director of DATADVANCE, and I'm here with Anton Saratov, our Head of Application Engineering. We are here to then continue the presentation we started in the first session. So please let me share the screen. So today's webinar is the second one, and we're going to speak about the low-code workflows. So from low-code workflows to analytical and optimization web services. But before we dive into the topic, I'd like to, as always, introduce very quickly the product and the company. Before I do so, a little bit of logistic information. So we're going to run a Q&A session at the end of this presentation. We have a 1-hour slot for today, and you can ask all your questions using the Q&A option you have in the control bar of Zoom. So just push it, and then you can ask your question. Your questions will be private, and I will pass them to Anton or myself. If it's sales related at the end of the session. So without further delay, let's jump into the topic. So let me just remind you that DATADVANCE is a software editor specialized in design space exploration and optimization, as well as predictive modeling, which leverages the power of machine learning and AI. And in the past few years, we have also very much focused our developments towards cloud collaborative engineering environments. So this is obviously the topic of today with pSeven Enterprise under the spot. We come from a research project at Airbus. So 10 years ago, the company was created after this research activities. The company was run during 3 years by Airbus, and then the handover to private investors was done, which brings us in 2015. Headquartered in Toulouse and with worldwide presence, typically thanks to a channel of resellers all around the world. And since the early days from Airbus and aerospace, we have now deployed our and distributed our technology to all industries. So energy, automotive, continuous manufacturing, chemistry, luxury goods, and so on. So the product line is about our main expertise, which resides in algorithms. So the first product that we commercialized was pSeven Core in 2010, and this is an advanced algorithm library in Python. So you need to do Python programming to run optimization or to do surrogate modeling. So to facilitate the usage of these algorithms, we have built a few years later on top of pSeven Core a graphical interface called pSeven. So you might have heard about pSeven v6 or pSeven Desktop. This is it. So this is a desktop application on top of the pSeven Core, and also providing the workflow automation capability, which is so useful, of course, for running in loops for an optimization campaign, for example, and without human intervention. And then more recently, in 2020, we have released the pSeven Enterprise. So pSeven Enterprise is a native cloud solution. So this is all our expertise in the cloud. So we focus very much, as you can imagine, on collaborative capabilities. I'll come back on this later on. So this is what it looks like. So pSeven Enterprise is of course a software that you will access from a web browser. So you don't need any local installation. You just need a web browser like Chrome or Edge. You connect to the server, to that URL, and then you can see your workflow. You can build your workflow. You can run your workflow, and you can do some post processing. That's what you see at the end, at the back. Sorry. On the left-hand side, you have what we call the pSeven Enterprise AppsHub. So this is a library of small web apps which are representative of a given workflow. And today you will discover how easy it is to switch from a workflow representation, which is provided in the center, to a web app. So Anton will explain how to do this. Then all of that also rely on a very solid foundation in terms of algorithms. So as you can imagine, the entire pSeven core is there with machine learning algorithms, MDO, so an optimization or design space exploration algorithms. Smart selection to automatically select the right algorithm and tune it is also present in the package. We have a specific block that you can use in your workflows to call the all these algorithms seamlessly. So you don't have to script anything here. It's really no code. Just specify the type of target or objective, for example, for an optimization, your variables, your constraints, and that's it. And if you don't want to use our in-house, let's say, algorithms, you can bring your own. So if you are familiar with TensorFlow, SageMaker, Scikit, etc., Keras, you can. pSeven Enterprise is very open with REST API and generic blocks, so you can easily integrate your own algorithms within the platform. The architecture is cloud, native cloud. So everything runs in the cloud in a monolithic fashion. So you start creating or assembling a workflow directly from your web browser in the cloud. You can run it there and then do the post-processing. You can deploy it on a public server or a private server like Amazon Web Services, Azure, or something else, DigitalOcean. But you can also deploy it on premises. So if you need to run the system in a secured environment, let's say without access to internet, it's absolutely no problem. You can, we deliver the software, you deploy it exactly where you want, and you will operate it yourself. DATADVANCE doesn't provide the software as a service. So it's not a SaaS solution. We deliver the software and you deploy it and operate it yourself. We can help, of course, in the process of deployment, but we don't operate as such the platform. It's a Kubernetes architecture, so it deploys on a Kubernetes cluster thanks to Helm and containers in Docker format. The collaborative aspect is pushed to the extreme with this concept of co-authoring. So two users can actually run or create edit the workflow at the same time, so simultaneously. And once the workflow is created, then you can make it a small app. So that will be the demonstration for today. This is what the library looks like. So if you are not data scientist or optimization experts, no problem. You can go to that library and select the app you need, and then the user interface will not be the one on the left. It will be something much simpler to use and very convenient. Here is an example with a snapshot of a smartphone opening such an app. The pSeven Enterprise architecture is very well suited for digital twin approaches because it's by nature, it's a cloud architecture. And secondly, because it can really provide hybrid digital twins. So it can mix digital twins coming from pure data and pure data science, so based on machine learning, all of that mixed with then simulation-based twins, where you actually run some physical or some simulation software based on physics and not based on data. So you can mix all of that and add on top the optimization, for example. So the workflow itself can be extremely sophisticated, and this will be the hybrid twin that you want to then connect to a physical asset. So here in that on that slide, you see that the physical asset, a wind turbine, then is equipped with sensors and actuators, So the sensors are pushing the data to an IoT platform, which communicates with pSeven Enterprise, which runs a complex workflow in the back. And pSeven Enterprise can send back some predictions, either to an operator working on the IoT platform, or potentially even directly to the physical asset. So that's the pure concept of digital twin. To extend the capacity of pSeven Enterprise, we have an open API that is needed to interoperate with external collaborative systems like SPDM platforms. So the couple between enterprise and SPDM platforms is really powerful, because then you can ensure the full data traceability and pedigree based on all the simulations you run. I'd like to finish with a very nice and successful project run at Technip FMC. So Technip FMC is one of the market leader in oil and gas services for subsea systems like spool risers, and they have deployed pSeven Enterprise in this and rebranded actually under the name Arena. They have actually captured many of their internal best practices within pSeven Enterprise, and it has been very successfully deployed with this outcome. So right now, since then October 2021, so it's like 1 year, they have 20 active users with successful training delivered to various offices in different countries. Deployed successfully on major projects, and the productivity gains is quite impressive, because they can see that engineers can perform 2 or 3 times more simulations compared to the manual approach. So with very high level of satisfaction, so which is good to hear. Wanted to share with you that outcome. So that concludes my intro, and I'm now giving the ball to my colleague Anton.
Yes, hello everyone. I will share my screen, and I hope you see it now. And I will start with the brief introduction in form of slides. In my story, I will have to proceed from the point where we stopped on the first webinar, because in the first webinar we checked how actually we can use the low-code workflow engine in pSeven to create the workflows and collaborate in this creation of workflows to capture our processes. Today we will talk about how we can transform these workflows into web services to be used in the broader ecosystem of different tools. So what did we have last time? We need to build, deploy, and use different models and processes in the form of automated workflows at scale. So we have multiple users, we have several departments, different models, all coupled together to capture our simulation methodology in like a fully automated manner. It may be difficult to build such complicated workflows embedding different processes, different submodels from different people. And of course, it all makes sense when we introduce such methodology at scale and many people use something which small group of people like Metaton Tools department created. So last time we checked how to capture the methodology, reuse it in a form of workflow, prevent from unauthorized modification using the custom block development, which captures on a smaller scale our processes, and how it's easy to adjust and assemble the workflow for a new use case thanks to low-code approach. Today we will focus more on how to share these workflows at larger scale, and also how to use the workflows as services, as like web black boxes for external systems in our ecosystem of instruments. And it leads to the fact that we need to use our workflow as backend and provide the easy, simple access to it from either outside, thanks to API, or in the form of simplified user interface to enable the non-expert users with a simple, let's say seamless usage of our tools. And that's what we will discuss today and what tools we have in pSeven for that. Last time on the previous webinar, we focused more again on workflow, orchestration and automation, on the block development and the available blocks and a multi-user collaborative environment. This time we will complete the picture with development of applications or web services from the workflows. In fact, it can be done in one click. We will check what's AppsHub in pSeven Enterprise and how we can enable interoperability thanks to REST API. Actually, any workflow in pSeven immediately upon creation and automatically is available as a web service thanks to REST API of the platform. And this REST API enables several ways of thinking about this workflow as a tool. First of all, it's workflow as a service. We assemble our workflow, we capture our process in the low-code environment from existing blocks or custom blocks. And when we see that it's automated, we can actually call it from other systems like an OSPDM to be used as the web service. Another way of doing things is more oriented towards final user direct usage. It's apps. Apps is a simplified representation of our workflow. So there is still a workflow in the background. It acts as a backend of our application, but there is also a simplified, or better to say, dedicated user interface, which enables the everyday usage of this app without knowing the complexity, without seeing it, without the need of changing it, but with the convenient tools to set our parameters and actually run the simulation. There is a way how to make our workflows almost interactive in terms of response time, and we will also check that. So what are the applications? It can be integration with external databases or data streams when our workflow subscribes to some incoming data in an automated way, processes these inputs to provide the outputs, for example, the quality predictions based on sensor data and so on. It can be on demand or even on event calculations. So our workflow is ready, and when something happens, it may be just a scheduled process, like every morning we do our simulation on schedule, for example, to recalibrate our simulation model to be accurate for the new operating conditions and so on. We can do predictions and simulations, so ML or simulation-based workflows or hybrid mixtures and pack them as a web services. We can also do online, let's say almost online, in time optimization for digital twins. When we have our model representing the real equipment, we have incoming data from real equipment, and we need to tune our model in order to give us the recommendations or just a more fitted model for the given incoming data. And we can, of course, organize the integration with this PDM platform, where pSeven as a PIDO tool will provide like a low-level simulation flows, simulation resources, all that direct integration capabilities. SPDM topic is a topic of the next webinar with more details and the use case presentation, so we won't focus on it today. Apps and AppsHub. This is a native pSeven instrument, which is designed to create this simplified user interface and publish it as a web application from our workflows. So actually, when we're working in pSeven as power users, as people who assemble and capture the methodology of the simulation, we work on the workflow level. We organize our logic, tune everything, check it, that it works. And after that, we can publish it, which is actually one-click operation, which transfers our workflow from our home folder, we will see it in live, to a specific place, which we called AppsHub, provides it with some description and so on. And in the AppsHub, each workflow has the customized or standard auto-generated user interface on top of the workflow. So the final user of the apps, he doesn't see the complexity, he doesn't see the workflow, he sees only the inputs he needs to provide to run the particular typically pretty well formalized and narrowed simulation scenario. So that's the AppsHub, and with this user interface, we may think of it of pretty comprehensive but still engineering calculators. With the story of workflows acting as the backend for our solutions, and when we call them from outside, either from apps interface or from external systems, it's important to remember that it's all cloud-based, and pSeven will take care about the resource management. It will allow you to spread your simulations across a heterogeneous environment, float some tasks to Windows machine and everything. So all that benefits of cloud-based centralized deployment with the resource management on top are here, and they may be even more important when we're talking about the workflows as services. We want just to throw the request for the simulation, and we should get our running instance and then get our responses without thinking where it's all happening. So this part about the backend orchestration is also an important part in this workflows as services approach. Talking about broader integration, when pSeven becomes a part of the huge ecosystem, we may refer to this schematic representation of kind of stack of technologies, where pSeven Enterprise acts as ML or simulation studio. We actually capture our processes, we create our simulation or prediction services. In the scope of IoT environment or ML environment, and in this field, in this area, we act as a layer. So there is some external or internal data sources and models, sensors on the equipment, and so on. Then there is a layer of data gathering, data governance, data storaging. These are dedicated systems in the IoT world, well developed, plenty of them. Probably you know some of them and even use some of them. And then on top of that, we have still this place where we want to create our simulation or prediction tools on top of this data. And that's where pSeven Enterprise comes into play. In a low-code environment, easy and fast, you organize your simulation processes and you connect them to your data storage, either as the conscription on the data streams, or as the just direct connection via API of those systems. And that's where the workflow as services becomes even more important, because it's full, becomes an automated exchange machine to machine. There is even no user interface in pSeven. User interface in such stories typically is another layer with the business apps more focused on the representation of the whole set of data, including the online incoming data and predictions together. So that's kind of the top level of complexity of using pSeven as the part of the stack of technologies in the IoT full solution. Unfortunately, we won't be able to check it today, but I will have a simplified demo on how it may be organized. Still the same live demo example as we had on the previous webinar. It's about the pultrusion process, which is continuous manufacturing. Last time we considered how to organize our simulations of this process based on simulation model, and how to run optimization to investigate, to study which process parameters will lead to the best quality of our process, so kind of prepare the recommendations for the lab in the design mode. This story also includes a nice example of request for fast predictions. Imagine you are working in the lab and you have your equipment in front of you, and you need a fast way to estimate what will be the product quality for some new process parameters you're going to set. In this case, you may use the app in pSeven Enterprise, which covers the complexity of all those simulations and everything, or uses the ML model in order to get your predictions in one click, even in smartphone using the app. Or we can imagine that there is the biggest story and there is a sensors on the equipment, which collects, for example, the temperature of material, which comes into our pultrusion process. And based on that, we want to automatically redefine our recommended parameters for the best performance and still satisfy the technological conditions. In this example, we have a limited number of parameters. It's pulling speed, which how fast we produce our product. We have temperatures, initial temperature, which may be again considered as the external knowledge coming from sensors. We have our settings for the heating chambers, which we can control. And our main quality criteria is cure or polymerization rate. So how good was our polymerization inside the product, and it's only coming from simulations because we cannot measure it from outside. And also we have some limitations of temperature, and our goal in the end will be to actually increase the processing speed. So that's the setup for our story. Scenarios. First scenario is a simulation process automation. We checked it last time. From this scenario, we immediately get the repetitive simulation task, which is parametric study. So for different combination of parameters in automated manner, we need to receive the different responses of our simulation model. And of course, the optimal process design, or optimal design if it's not a process, but a part. Which is again the reuse of our simulation process with the goal to find the combination of parameters which leads to the best performance. Today we'll focus on the second part of this story. So prediction modeling from our DOE or external sample of data, coming, for example, from external database where we store our historical data. That will be an auxiliary step for us just to get our prediction model. And a fast online prediction using surrogate models as the response source in the form of the services which can be used by final users to get the estimation of the performance quality. And to be mentioned, optimal process design or optimization as the workflow also can be used as a service. Here we will check how it can be done. When we say workflow services, external usage, everything else, it's more important to remember that there are always some third-party tools, data sources, data streams, databases, SPDM, and actually here the REST API allows you to tie all those tools together to get your final ecosystem with data gathering, predictions, and visualization, maybe even in a third-party environment for business analytics. So that's our scenarios, and let's check it in live. So what we will check today is how to turn your workflow into the app. What can be the story with the optimization study as an app or a service, how to organize interactive exchange, and here the predictive modeling will be important because it's a fast way to get our responses, and we want our services to be fast to use this advantage. Then the example of app with a custom UI, because pSeven allows you to develop your own UI for the app of any complexity you actually want to. And in the end, we will check how the external calls to the workflows and services can be organized via REST API. So let's switch to pSeven Enterprise. Last time we checked a bit how the workflow creation, assembly, how is organized, how it works. We also checked how to develop our own blocks to capture the important parts of the process for further reuse. And here I will start with the workflow we assembled last time. This is a single simulation workflow, pretty straightforward process, similar to many simulation tools. We prepare our input file, we run our solver in a batch mode, command line. Here we, by the way, run it on the extension node, a Windows machine attached to pSeven resources pool. We post-process our results and get our outputs. So one of the most simple workflows in the simulation automation world. And this workflow accepts the 4 inputs set by user and provides us with 4 outputs with a simulation outputs. And as I mentioned, any workflow in pSeven, even when it's here in my possession, in my home folder under my control and during the editing process, is already a service in terms of the external interaction. So REST API of pSeven provides you access to all workflows and will allow you to specify the values of your inputs from external requests, launch a workflow of execution, upload the files which this process may need during the run, and then when it's finished, you can check the status, extract the results from external tools, and download the files you need. So here we can go to the REST API page. I have it already opened, and see in the kind of visual representation what API will return us if we will request the details of this workflow. Yeah, it's a lot of text, but we can check the name. So that's the name of our workflow we just saw in real mode. And we see our parameters, which are our inputs of the workflow, T0 with the value T1, T2, our temperatures of the die chambers, and the pooling speed as input parameters, as well as results, which have a null value yet because we didn't run the workflow, but we will know which values we can extract later on. And this visual representation of REST API gives us the first idea what we'll be able to do. We will be able actually to parse the contents of the workflow in terms of inputs and outputs, set up the inputs, run, and extract the outputs. That all can be done in external scripts or tools for API exchange. I'm showing this thing not because of the details, which are not important here, but more to illustrate the fact that actually I did nothing to make this workflow to be available as a service. It's automatically happening as soon as I create the workflow and set up inputs and outputs, which are my controls. Also, when you create a workflow and set up inputs and outputs, pSeven automatically generates the user interface, the simplified user interface for this workflow, again, containing input parameters and expected output parameters. I will show it, but on the example of optimization workflow, which is a bit more interesting in this case. So let's switch to optimization. A bit more complicated workflow, still pretty transparent in terms of structure. We have our simulation model here in composite block, the same one for single simulation, but now it's running in the cycle. We have additional block just to return the target function, which is our pooling speed. The whole story is to increase the pooling speed while satisfying all the constraints from technological requirements we have. And we have our inputs setting up the range of variation for our optimization parameters. So here it goes. It's just a lower and upper bounds for our active parameters. We have also the injection of our T0 parameter here, which is our external parameter. And as a result, we get our optimal values as recommendations, which parameters to be set on the equipment in order to reach our goal. So workflow is created, checked, and we want now to use it as an external tool, as an app. Again, if I will go into workflow folder, I will see that there is the UI folder already created by pSeven. That's where platform created the simplified representations of this workflow for you. We can go here and find that it's some kind of web files, and we can even open it to check what it is. It's automatically updated once you change your structure of inputs and output ports, and kind of follows the changes in your workflow. But I won't check it here yet. I would immediately proceed to publishing, since I have my inputs and output structure fixed, and I want to enable other people to use this workflow without even knowing what's going on, just to set up their problem. For that, I also can do it in one click. In the menu, I have published to AppsHub. I need to provide some description, picture if I want, and so on. And actually, when I will click the publish button, my workflow will be transferred from my home folder under my full control to a dedicated place called AppsHub. This is just a part of pSeven platform. And pSeven will host my workflow as the backend and my UI of this workflow as the front end and the user interface in the AppsHub. I have this workflow already published, so let me switch there. I will go to AppsHub. It can be done here. I have it already opened, and it looks like that. By the way, we have we may have dedicated users who have only access to AppsHub, so they're not allowed to go into full platform. They only work with these tools. Here we have a lot of stuff in our demo cloud, but I'm interested in two recent one I published just for this webinar, and this is my optimization. Let me open it and see what the standard default interface looks like. Well, it's pretty simple. I have some description. However, I can customize it to bring more details about my problem, some recommendation of problem statement, and so on. And again, the mapping of my inputs and output parameters of the workflow. So what I have here, I have T0, my special parameter, which I may consider as external coming from sensors or whatever. And the bounds of my optimization, which I may not even want to vary during my study. They are set in the wide ranges. So let's imagine we're doing our global study for best performance parameters. I can also control how many evaluations I can do, just because I also propagated this parameter as the input of workflow. So this interface, despite it's an AppsHub, it's just a coverage representation of my inputs and outputs of the workflow. But for the end user, it contains only the parameters he needs to use or may want to use. As outputs, I will get my optimal designs. I won't run it now, but of course I can run as many as I want, thanks to cloud nature of the platform. So it can manage dozens of runs from different users at the same time. But I already have one here, which is finished. And I can go there and check what will be the final form of the app looks like. And it actually contains my results. So vector representation of optimal design, and each important output as a number. So it recommends me to go with the pooling speed of 1.06 centimeters per second and raise the temperature of my dies to the upper bounds, which will produce the best cure of level of 0.8. I can also download the files like optimal designs to CSV and check it on local machine. And that's all was made without any web development by programming, fully generated by pSeven automatically. We can enrich this interface. Actually, we can develop our own interface of any complexity and literally replace the standard generated interface in the folder of the workflow here in the UI. One consideration to be taken into account is that in the end, this UI of the app is still a representation of the workflow. So yeah, we always tend to dream of very complex visual representation, but the best practices is workflow first. So workflow contains the logic, workflow contains the inputs we need to set, and the UI simplifies the setting of these inputs. So for example, it may be additional check of consistency of my inputs. It may indicate for the user that I missed some settings which are important, or just provide more useful controls for more important inputs, and the rest are somehow hidden. But still, UI of the app is the representation of the workflow with the simplified visual view. And that's kind of a natural limitation of how far we should go with the UI development for the apps. If you want a real extended dashboarding system with complicated plots, a lot of maybe other sources of data except for pSeven workflows, that's the story of, say, full stack technology, where you have external dashboarding. That typically happens when you already have a developed data storage, data gathering, and data visualization tools. And there pSeven can act as the provider of, let's say, web black boxes. Anyway, Before we'll check the custom UI of the apps, let's remember that I announced the ML part of the story. ML here and hybrid approaches is also can be captured as workflows. One story for model machine learning is actually building our model, and it also can be made in the form of the workflow. Very simple one is here. So some data loading, some training of model, and validation here on the sub part of the same training sample. So it's a test sample. Even though it's a simple task, it's a workflow here, and it makes sense. Imagine you have typical situation when you have a lot of similar pieces of equipment, and you know that you can approximate the performance or behavior of these units. But you, for example, have your data updated, you gather more and more historical data, or you have a new unit which you need to also approximate and replace with the prediction model. In this case, the automation of the model training itself is also an interesting task, and you can use this workflow in like fully automated manner. Just throw new data set or connect to new instance in database for the new data, train the model, validate it to make sure that it's accurate enough, and you have your model to be used as a part of the simulation or prediction workflow. So as an auxiliary way to use the automation platform workflow to train your model, but we're actually looking for the way how we can run our predictive model. Of course, you can say, yeah, same manner. One block, which actually takes my prediction model, receives the inputs, outputs the outputs. That's a working solution, maybe more complicated than one block with additional check of the data, maybe normalization, post-processing. Yeah, as simulation. What is different? One thing is different with prediction modeling. We expect predictive models to be fast. And here we will have unavoidable mainly time here spent to actually run this workflow, because we are working in the cloud environment, distributed resources, resource management, other people running their workflows. When we will start this workflow, pSeven will take some time to find the slot where it should be executed. That's a drawback of this distributed resource management. Yeah, this lost time can be small, it can be seconds, but our model is predicting in a fraction of a second, and we definitely don't want to lose this benefit. Here, in the world of, let's say, ML predictions, a special structure of the workflow may come into play. And it's the, let's call it a cycle which never ends, or a waiting workflow. So what we see here, focus on this part, is the block which actually listens to external requests from REST API, because we will use this workflow as the service. And once the new data arrives for prediction, it runs the cycle with our ML model, receives the predictions, and send it back to the API client, which send the request. This workflow is running forever. So we run it and it waits for this new request. And this initial, let's say, time spent for running allows us to get our predictions in a fraction of a second, because no resources should be allocated anymore. Our service is active. That's a bit of a difference of pSeven compared to maybe direct service deployment platforms and ML studios. In default manner, our workflows are disabled, and if we want to run it, we will spend some time to find the resources on the platform. But if we want to use them in a fast manner for immediate response, we may run them and let them be in this running mode. And in this case, we will get our predictions immediately with a maybe small additional time spent for network interactions. This workflow is even more interesting than just a prediction from the ML model, because this is this internal cycle. This run manager block, it's a demo purpose here, of course, it's Python script, can also go to another cycle, which goes to simulation model. And this is a naive representation of hybrid approach, when we actually can switch. Either we want to go with fast, but potentially not accurate prediction from ML model, or by external control, additional parameter, which just acts as the driver to go either this way or this way. We can go to full simulation, pay some time to get more accurate results. This idea can be extended, of course. For example, this switch can happen automatically. If user requests the point which is outside of the domain where we have our ML model accuracy high enough, it will automatically go into full simulation. But for the moment, we prefer this in these use cases to notify the user that he's going to go for longer simulations. Also, the workflow engine don't prevent you from having workflow combining simulation and ML models into one chain. Here we have 2 branches and we decide which one to go. You can of course combine them, and it will be more complicated and more realistic hybrid approach. But even here we have a nice switch, fast, potentially not accurate, fraction of a second, or full with simulation, but yeah, we will wait for the time simulation will run. Platform allows both. For this one, we have an example of custom UI in the AppsHub. If I will go back to my AppsHub and check this interactive example, it's also the same workflow already published before the webinar. I will open it and I will see this more convenient or just nice looking interface. In fact, it doesn't change much from the one we saw is auto-generated, because we have still 4 inputs and some 2 outputs, which are important for us. The only difference in this case is that we have 2 buttons to calculate approximation, calculate simulation model, and that those buttons will actually define the switch. Either we go one cycle or another cycle in our waiting workflow. And as I told you, we are using the workflow which is already hot. It's already deployed for execution and just waiting for us to ask for prediction. For that, I will check, yeah, I have one running. I will switch to it and click calculate approx to see how fast it can be. Calculate approx and no time. You see the cure and temperature immediately updated. I have some nice notification that it was got from simulation model. Of course, I can change my settings. Okay, it's very low cure rate. Let's heat up our dyes, and that's maybe the actual usage scenario. So I'm in the lab and I say, yeah, it's too low. What should I set if I will go for faster production, but also heat up my thing, calculate approx. Yep, still not enough. Let's heat it up to max and not be so greedy with our production speed. And we can get our 80% threshold satisfied. And that's our way to check our assumptions, which settings will be good for our process. This, of course, is direct prediction. So I have my assumptions, I check them. Literally in the same manner, you can organize the app for reverse or inverse problems, either, I mean, for optimization. We saw it in the standard interface way of doing things. Of course, it will be more time consuming because any optimization is orders of magnitude time consuming than the direct prediction with ML. I can also switch to simulation model or interrupt, switch from different profiles of my product. So that's the example of nice, convenient way of creating the custom app on top of the workflow. Still following the idea that I mainly want to control my inputs and check my outputs, yet in the way which is more suited for the actual usage scenario. last thing I wanted to show and highlight is actually this story of when the workflow acts as a service and external tool. Let's go back to our workflows. Same workflow, but yeah, exactly same in fact. And I have it running in my home folder. You see, it's running. I have it that way just to show you the fact that I can both run the workflow from outside or like send the data and still even see how it's running in my home folder. It won't be possible in the AppsHub because in the AppsHub, I don't see the workflow itself. Here I see how it's flashing. I hope it will be more representative. What I'm going to do, I have this workflow running. I will switch to my imitation of, let's say, external system. That's just some code based on our standard example of API client, which we provide with trainings and all examples we share. What it will do, it will generate some values for my external temperature T0. And I would like to send those values to my workflow, receive back the predictions of my cure rate, and see how it evolves with the evolution of my external temperature changing. I will rerun this part, and this is my naive dashboard. I'll let it, Matplotlib here is slower than pSeven Enterprise web service. Yeah, so what I see here, external temperature and measurement point. It changes in a random manner with slow decline. While the cure rate here on the top plot is actually the result of my workflow simulation. So this blue line, green line is something I generate here in the client. It is sent to my workflow in pSeven Enterprise in the cloud. So client is local machine. pSeven is in somewhere DigitalOcean. And I will see how for different values of external temperature, my cure rate will evolve. This dashed line is my kind of a criteria of quality. I should be higher than the dashed line. So it evolves every second or so. I produce a new point which imitates the data coming from the sensor. And back on pSeven Enterprise side of things, my workflow is flashing. And you see that, yeah, the count on my approximation model raises. So this driver block receives the message from my API client back there and runs my workflow for another cycle of prediction, collects the output, returns it back to my plot, and I see it there as an evolution in time. So that's how you can easily use your workflow as an external tool. Again, the modification of our standard API client here is minimum. Of course, this is a naive example, but I hope it gives you the idea that you can actually use your external dashboarding tool or existing or something bigger than only pSeven and actually refer or utilize all the power of low-code workflow editing engine to create such workflows as services without even deep knowledge of programming. Here I see that my external temperature is declining and my cure rate is going to hit the boundary. So if I had a full dashboard, that may be a signal for the operator that something is going wrong and we need to refine, tune our process parameters to return back to desired quality of the product. This is kind of an example of the iterative thing. To complete my intro, it will still be running for some time. I don't think we need to wait until it will be finished. I guess the idea is clear. I will return to AppsHub and comment on what's going next here in terms of development, because it will be available already in the next version, so 2 weeks. Here we see our apps, and we can go there and check their interface. We can make it more like a list view. But we don't have these tools to control how those workflows in the AppsHub works as a services. We don't have a summary of what's running and what's not. It's not needed for the application scenario of engineering calculators, because in this case, I will anyway go into my app and work directly. But if I would like to use my apps in the AppsHub as services, I would like to have a summary. And that's what's coming again in next release is the run center. So the AppsHub will be complemented with a centralized control of different runs of different apps or workflows in order to extend the usage of workflows as services. So single control point, status, versions, tracking, deployment options from single page to start, stop, schedule the run of these services, and even auto restart for the waiting workflows in case something will go wrong. With this announcement, I would like to finish my demo and presentations. Thank you, and your questions are welcome.
Yeah, thank you, Anton. So yes, we have few questions. So let's engage with the Q&A part of this webinar. So the first question is the following: in case of a workflow interacting with external data platform, how do you connect to it? Is it a Python script or do you have like SQL connector block?
Okay, that follows the same idea that I presented on the first webinar with the custom block development. We have some experience with connection to like MySQL or Kafka data stream, either in the form of customized Python script, because sometimes you would like to tune your block in a like more programming manner, and also in the form of creating dedicated connectors. But these connectors, in my understanding, shouldn't be like generic connector to, I don't know, some type of database or external platform. They should be also be more tuned towards application scenarios. So that's where we also use custom blocks, and we have some of them available for some platforms, again, like Kafka data stream.
Okay, next question. So what is the response time limit for workflows for real-time prediction?
Okay, that's a good one. So of course, first limiting factor is the time of the evaluation itself. So if you base your interactive workflow based on simulation model, simulation time will be the main limiting factor. With approximation models, there's still this time to be spent for actual evaluation of the model, even if it's in pure Python script or whatever. So what we can estimate is how much we add on top. So how much is the relative time spent for all this network and platform communication. And we may say that it's with huge safety margin, less than a second. So yeah, it's not a massive online prediction. It's more like, you know, in time interactive prediction. So for processes which develop on a scale of seconds, which is still pretty fast even for real engineering equipment.
Okay, thank you, Anton. Next question: is it hard to create custom UI for applications? I guess the person wants to hear about the process here. Or can you elaborate on the UI creation?
Yeah, that's a big one because there is so many influencing factors here. So getting back to this UI, this UI, as I mentioned, is pretty tightly linked to the format of inputs and outputs. So actually we have like nice visual sliders, but they still set the parameters independently and so on. So this is the first thing to be considered. How far you want to go into customization, because in UI development, additional small features can suddenly lead to more to kind of non-linear increase in complexity and cost. Second thing is which tools do you use? Here we are really agnostic to how you will develop your UI for the apps. We're agnostic to the fact that we don't provide any, I don't know, construction tool to combine the UI, or we don't force you to use any framework. There are frameworks which are pretty easy to use, And for example, this interface was created by simulation engineer. So it's not even the app designer. And of course, the AppsHub provides you some nice features which are already embedded, like the navigation through the last runs and so on. So you have some parts ready for you. Then there is the way to take the standard UI and add some custom parts into standard UI. That's typically the part where you would like to add, I don't know, picture of results into your UI. That's again maybe on the side of simulation engineer who learns a bit where to copy paste this thing, and that's pretty cheap. And then we go into the terra incognita of pure custom UI developed from scratch for your needs. We have a couple of examples of those. In those cases, such interfaces bring additional business value, but that's a dedicated work for UI designer. So we don't limit the complexity, but the basic things can be done sometimes even without involving the dedicated UI person.
Okay, then this will be the last question, Anton. Can you run workflows on schedule, like every day at a given time?
Okay, not yet. So that will be definitely a part of this run center thing, to have this cron to schedule the run of the workflows on a regular, but let's say not very often basis, like every morning, yeah, once in a day. But we also need to remember that we have this mechanism, and we can have this block running the workflow, which is the rest of the workflow, like once in an hour. So there is a kind of a place where you may decide to go into always running workflow, which performs a simulation once in a given time. That's already available via this mechanism of waiting blocks, or using run center, which again will be there in less than 2 weeks, to schedule your workflows like on a daily basis or via calendar or cron there. So yeah.
Mm-hmm. Okay, thank you, Anton. So that concludes the Q&A session. We don't have any more questions. So thank you all for your presence, for your interest. Please let me remind you that the last session for this webinar series will happen next Wednesday, so 1 week precisely from now, same time, and this session will be dedicated to the integration to SPDM SLM systems. So don't miss that. This is a very trendy topic. SPDM is very complementary to environments like pSeven Enterprise for, of course, managing data and ensuring traceability. So we wish you could join, and we look forward to having you on board for this last session. Thank you, colleagues, for your participation, and have a good evening. Thank you all. Bye bye.
Thanks everyone. Goodbye.